This is your class lesson for part 2 of section 3.4, composition of functions. We'll begin with composing functions f and g. Both of those functions are given there. Let's begin with f composed with g of 2. And by definition, that is f of g of 2. So we always write this f on the outside, and on the inside we're going to find g of 2. Now I'm going to go somewhere else on my paper and find g of 2. And g of 2 is 2 over 2, which is 1. So guess what? Now all I have to do is find f of 1. And if I go into f, the f function, I'm going to take the square root of 1 plus 4, and that's equal to the square root of 5. Okay, let's compose g composed with f. So g composed with f of 5 is g of f of 5. G of, and now I'm going to go somewhere else on my paper and find f of 5. And f of 5 is the square root of 5 plus 4, square root of 9, which is 3. And now I'm going to go find g of 3. And g of 3 is 2 over 3. Okay, let's go to number 2. Now notice the difference. We actually got numbers or values in number 1 because we were composing functions evaluated at x equal to 2, x equal to 5 at different numbers. Now we are composing with x, and here we will get formulas. Okay, so f composed with g of x by definition is f of g of x. F of, and you go find g of x and you write that down right there. Now, this tells us to go to the f function, and everywhere there's an x, we're going to put all of 2x plus 5. So we're going to have the square root of 2x plus 5, and then we still have minus 1. Again, this is our x, okay? So that's the square root of 2x plus 5 minus 1, and that's the square root of 2x plus 4. Okay, now let's go ahead and talk about the domain. There's two things when you talk about the domain. I always say it's the inside function and the new. So we can say that a few times, inside and new. Inside and new. So you will take the most restrictive of the inside function and the new function. The inside function is 2x plus 5. And the domain of the inside function of g, inside function is g, and that domain is all reals. It's a polynomial, it's a linear function. Now, our new function is the square root of 2x plus 4. So what do we have to say? 2x plus 4 has to be greater than or equal to 0. 2x has to be greater than or equal to negative 4. And x has to be greater than or equal to negative 2. So our domain of this new composite function is negative 2 to infinity. Let's try g composed with f in the same manner. Let's do the same thing. By definition, that's g of f of x. That's g of, and we go find f of x, which is the square root of x minus 1, and we put that. That is what we call our inside function. Now we're going to go to g, and everywhere there's an x, we're going to put the square root of x minus 1. So we have 2 multiplied by the square root of x minus 1 plus 5. Now, we also have to go ahead, g composed, 2 times the square root of x minus 1 minus 5. Yes, that's it. So let me highlight that yellow because that is our new function. That is our composed function. But now we have to find the domain. And for the domain, we find the greatest restriction on the inside and the new function. Our inside function, it's this one that went inside, right, is the square root of x minus 1. And our new function is 2 times the square root of x minus 1 plus 5. Well, if you have this inside function, x minus 1 has to be greater than or equal to 0. So x has to be greater than or equal to 1. Now, what's the good news? It's the same restriction. X minus 1 has to be greater than or equal to 0. So x has to be greater than or equal to 1. So this domain is 1 to infinity. Okay? And let's take a look at our last problem. Remember, we can't have 0 in the denominator, so we do have to be very careful. But we have the same process. So f composed with g of x is f of g of x, f of 2 over x. Now we're going to go to the f function, and maybe I'll do it on this next line over here. We're going to go to the f function, which is right here. And everywhere there's an x, we're going to put 2 over x. Okay? So that's going to be equal to 5 over 2 over x plus 4. Now, we do have to clear this complex fraction, so I'm going to multiply the numerator and denominator by x, and that will clear it for us. So we end up with 5x over 2 plus 4x, and that is our new function. Okay, so now we have to find the domain. So how do we find the domain of this new function? We look at the inside function and we look at the new function. The function that went inside was 2 over x. So x cannot be equal to 0. We have to throw 0 out for sure. And then the new function is 5x over 2 plus 4x. This 2 plus 4x cannot be equal to 0. So we will set it equal to 0 and see what makes it 0. So we also have to throw out negative 1/2. So we're going to throw both of those out. I'm not sure if you remember how to write that, but I think you do. We're going to write the new domain, and that is we're going to go from negative infinity all the way to negative 1/2, and we don't want it. We're going to jump over it. Then we're going to go from negative 1/2 to 0, and we don't want 0. We're going to jump over it, and then we're going to go from 0 to infinity. And there we go for that domain. Okay, let's go ahead and try B. And in B, we have g composed with f of x is g of f of x. It's g of, and f of x is 5 over x plus 4. You're going to like this problem. Now we're going to go to g, okay? We're going to g. And everywhere there's an x, which it's right there, we're going to put all of 5 over x plus 4. It's not going to look very pretty, but it won't be difficult. So what does g do? It says 2 over 5 over x plus 4. So don't worry. We're going to reciprocate that, and it's going to be 2 times, instead of divided by, x plus 4 over 5. And we end up with 2 times x plus 4 all over 5. And you can leave it like that. You can also distribute that to whatever you'd like. How do we find the domain? You guessed it. We have to look at the inside function And when I say most restrictive, that means you have to satisfy both of these. So inside and new, just say that a couple times, inside and new. So our inside function is 5 over x plus 4. And when you look at that, x plus 4 has to be greater than 0. Excuse me, am I saying? We have to set it equal to 0 to see what makes it 0. So x is equal to negative 4. We have to throw that out. So x cannot equal negative 4. Okay, let's go to new. Our new function is 2 over x plus 2 multiplied by x plus 4 divided by 5. Everything's good. You can let x be any value you want. We don't have any denominators with a variable in it, and we don't have any roots. So all we have to do is throw negative 4 out. That made it very, very easy. So the domain is negative infinity to negative 4, up and over negative 4. We're on the other side of negative 4, going all the way to positive infinity. And that